In this video, I'm going to find natural numbers a, b, and c that are going to satisfy the Pythagorean theorem, which is a square plus is equal to b square plus c square. That is to say that I'm going to find natural numbers a, b, and c such that these are the sides of a right triangle. First of all, let me remind you what natural numbers are. So natural numbers are 1, 2, 3, 4, 5, 6. It keeps going forever. So positive integers. So let's say we want to find a triplet or a triple as A, B, C such that it satisfies the Pythagorean theorem. By the way, these A, B, C are not in particular order, so don't worry about the order so much. It's just three numbers, A, B, and C. So we are going to find three numbers a, b, and c such that it satisfies the Pythagorean theorem, or equivalently those three numbers are going to be the sides of a right triangle. So one of the numbers is going to be hypotenuse, the other two are going to be this and this. So we need to find such numbers. There is a very nice and simple trick for doing that, and it's really simple and easy. So let's start off with two numbers m and n, okay, such that m is greater than n. I'm assuming that m and n are natural numbers. We are dealing with two numbers m and n, okay. M is greater than n, both are natural numbers. Then I call my a to be m square minus n square. I can do that. Now the difference of the squares of two integers, positive integers, is also going to be an integer. So a is going to be an integer. Since m is an integer, n is an integer, m square is an integer, n square is an integer, so m square minus n square is also an integer. So that you understand it. Now then I'm going to define b as my following number, 2 times m times n. Okay, b is equal to 2 times m times n. Now look, this is what we are going to get. A square plus b square, okay, is going to be equal to this thing squares, which is m square minus n square whole square, plus b square is 2mn whole square. Now remember the difference of, perfect squares formula for a minus b, so I'm going to use a different symbol here. X minus y whole square is equal to x square minus 2xy plus y square. Using that formula, I'm going to simplify this. In my context, x is m square, y is n square, so it's going to be m square square means x square minus 2 times x, x is m square, y is n square, plus y square. So 2xy is this, and y square is going to be n square whole square, plus 2mn whole square is 4m square n square, which is going to give me the following. M square square is m to the power 4 minus 2m square n square plus n to the power 4 plus 4m square n square. Now these two are like terms, I can combine them, keep in mind, is going to give me 2m square n square, which is positive, plus n to the power 4. Now this, by the way, is a perfect square. If I put plus, right, so I'm going to put a plus right here so that you can see it, is going to be m square plus n square whole square. So if I define my, so let's look at it. I found a square plus b square is equal to m square plus n square whole square. Remember, m square plus n square is an integer. So if I call c is equal to m square plus n square, then I have a square plus b square is equal to c square, which is the Pythagorean theorem. So this is going to be my C, this is going to be my A, and this is going to be my B. This may sound a bit abstract, but this is a very easy and simple example. Really easy. You can play around with any natural numbers. So if you come up with two natural numbers P and Q such that P is greater than Q, to find A, you just have to put A is equal to P square minus Q square, B is equal to 2 times PQ, then your C is gonna be P square plus Q square. So this is how you'll get sides of a Pythagorean theorem which are gonna have sides of a right triangle which would satisfy the Pythagorean theorem, and all the sides are going to be integers. This is a very nice and simple way of finding integer values for the sides of a right triangle. I hope that this discussion was not too complicated, hopefully helpful. Thank you very much.